the next 3 to 5 minutes, I'll make sure that you will know how to interpret an ABG. So while approach to ABG, the normal pH we consider as 7.35 to 7.45, the average is 7.4. If less than 7.4, we call it as acidosis. If more than 7.4, we call it as alkalosis. Everyone knows this. Similarly, normal bicarbonate is 22 to 26. The average is 24. If less than 24, we call it as metabolic acidosis. If more than 24, we call it as metabolic alkalosis. Normal PCO2 is 35 to 45. The average we consider as 40. If less than 40, we call it as respiratory alkalosis. If more than 40, we call it as respiratory acidosis. So now let us consider an example. This is our ABG. Step 1 is we have to see the pH. If the pH is less than 7.4, here 7.246, we call it as acidosis. Now step 2, we have to see which parameter is going in direction of pH. For that you have to see bicarbonate and PCO2. Here our bicarbonate is around 9 and our PCO2 is around 22. So bicarbonate is also decreased, PCO2 is decreased. Decreased bicarbonate we call it as metabolic acidosis and decreased PCO2 we call it as respiratory alkalosis. So which is going in direction of acidosis? Yes, this ABG is metabolic acidosis. Step 3, that is compensation. What is compensation? Whenever there is metabolic acidosis, that is bicarbonate decrease, relative H plus will increase. This relative H plus increase will stimulate the brain center, that is respiratory center. The respiratory center will in turn increase the respiratory rate and tidal volume. So there will be hyperventilation. Whenever there is hyperventilation, more amount of CO2 is removed out. So we know that CO2 plus H2O will form H2CO3, that is bicarbonic acid. So if CO2 is removed, the bicarbonic acid is decreased. So there will be alkalosis. So in order to tackle metabolic acidosis, the respiration will produce respiratory alkalosis. Okay. Now we will see whether the compensation is adequate or not. For every 1 milliequivalent of HCO3 decreased, PaCO2 will decrease by 1.2 times of delta HCO3. For every 1 milliequivalent of HCO3 increased, PaCO2 will increase at 0.7 times of delta HCO3. Just remember, PaCO2 and HCO3 goes in same direction. If this decreases, this also decreases. If this increases, this also increases. Now, most of the times we use Winter's formula in order to calculate the expected PCO2 in metabolic acidosis. That is 1.5 times of HCO3 plus 8 plus or minus 2. We will take our example. That is 1.5 or bicarbonate was 9 plus 8 plus or minus 2, which will come as 21.5 plus or minus 2, which is 19.5 to 23.5. So our ABG, we have PCO2 is 22. This 22 is in the range of 19.5 to 23.5. So it is well compensated metabolic acidosis. So we call it as just metabolic acidosis, or we can call compensated metabolic acidosis, or we can call metabolic acidosis with compensatory respiratory alkalosis. Now assume if our ABG showed PCO2 is less than 19.5, we still will say it as compensated. If it is more than 23.5 but less than 40, we will say it as partially compensated. So if it is greater than 40, we will call it as respiratory acidosis, that is metabolic acidosis. Also we have respiratory acidosis also.